Got it. Okay. Welcome to the July Fourth Interest Group, Silicon Valley Zoom meeting. If you are just joining us via the wonders of YouTube, you missed the lovely recording start ceremony. Hopefully you'll join us in real time. You can go to our MeetUp page and read all about it. The agenda will appear a day or two before the actual meeting. And then hopefully speakers will have announced themselves beforehand. Chris, what's his last name? Chris Lozinski sent me a meetup message saying that he wants to present today and he'd be here at 9:30. I don't see him. So when he shows up, we'll have to ask him. He wants to go to another meeting at 10 and then come back and present his present. So it may be next month. I wanted to say that in the olden days, pre-COVID, Dr. Ting used to take the opportunity in July to have a July barbecue. So we'll be commemorating that activity at Armadillo Willie's in Los Altos. There are too many losses around this place. Los Altos, and having a root beer to Dr. Ting's memory. So we hope those of you that are in the Bay Area that can join us for that. Without further ado, any new business, comments, questions, organizational details? Okay, good. Bill had the kindness to pre-record his talk, even though he is available, I guess, for questions after the end. So if Brad will light the fuse on that, press the go button, we'd be grateful to get started with the actual presentations.
Sorry about that. 1 second. Let me.
You haven't done anything wrong yet. You don't need to be sorry. In fact, you've been as close to perfect as one needs to be.
Well, good morning, good afternoon, good evening, wherever you are in the fourth world. I'm Bill Ragsdale. I'm the founding president of the Fourth Interest Group. And today we are going to have a presentation on Bill's Does. Actually, I use the original phrase, Bill's Does. It, of course, is now known as Create Does. We will go into some of the history as the presentation proceeds. So the history of Create Does started in 1969, or a little bit before that, when Charles Moore invented it. He started out with the Bill's Does as the construction. In 1982, he redefined or gave us a new formulation known as Create Does. And then finally, we'll talk about the current 2023 methods that are used in Win32.4. So what does it do? Well, Create Does, creates words, it creates words. You might call it a meta-defining word or an ultra-defining word. It operates one level above words like colon, comma, colon, variable, constant, and so on. It can be used to create those words, or you can actually use it in metaphors to define a complete form. Also useful for defining database fields, as we'll see in a few moments, and of course, assemble opcos. Most fourth metacompilers have an assembler, and it is written using Create Does. So generally, the factor on these words are that they have a common structure. For example, variables have their individual names, but they will have a particular memory location associated with them. So how's this done? Well, the parent word, and for today's work, we'll use the word parent, although it can be any word you choose. The parent word will create a family of child words that share a common execution that have individual parameters, and our discussion today will take those two elements apart, the common execution and the individual parameters. Here's an example. It's a silly word that really doesn't do anything, but we're defining the word parent, which uses create and comma. This will create a child word, and it will save a parameter for that word. The does part will be executed for that child word. So when child executes, it will do a fetch and a drop. Here's some examples. We'll define the word constant using create does. So create creates the word name, and comma puts the parameter of the constant into memory. Does simply fetches that value back. And we see down the next line down is the hex 10x, which we define as hex base. So every time hex base executes, the address of the parameter goes on the stack, and the fetch fetches it. This is an example of defining opcodes. Opcodes are a little bit more involved. They create comma, names the opcode, and takes its hex value saved as a parameter. Then when that opcode is executed, the parameter is fetched back, and the comma compiles it into memory. We see some examples there. 5f, hex value of 5f, f5f is the equivalent of a clear carry. Hex db is the opcode for push. So executing push will place db in memory. As an example, in a field for a database, this assumes a linear database as an array. Create will create the name of the field, and then over, comma, plus determines the current offset into that database, and the plus calculates the offset to the next term. When this executes, the fetch sign will pull the value, the current offset value of that field, and then add it to the origin to give us the dedicated memory spot within that array. So we see here we're building the field.
Eigentlich nicht so sehr.
Wait.
Du hast ja noch eine Semmel gegessen.
Ja, und du?
Und als ich dann ein bisschen Appetit hatte, habe ich dann auch.
After that executes, if we use field will take the offset of 20, assign it to age, and it will add the size of a cell, which is 4 bytes, to age to generate the next word, which would be weight. And so weight would be at 24 bytes into this array, and at the end we drop the accumulated parameter. Executing each of these names will put its offset physical address onto the stack. So rewind to some history. In the 1960s, from about 1966 to 69, when Charles Moore was developing Forth, he created the bills does form. We see the use here. The parent word uses bills, comma, does, at dump. Very similar to what we saw with create. The blue at the bottom is the words that are compiled into memory. The parent header is the full length header that defines the word. Ucol is a code to execute a colon definition, and then assembly combines a bills, comma, does, at drop, and encode. The child header has do does in it, and we'll see how that is added in, and then has a pointer to the execution code. So the parent takes care of building the word, and then the child header has the do does and the pointer to the execution code. Here's how it's actually developed. The builds word executes 0 constant. It builds the header and it reserves 1 parameter in the parameter field temporarily at 0. The does all the work. This rewrites the parameter field of the calling word, that's the 0 that was just defined, and it rewrites the code field address to point to the do-does code. The rewriting of that is done simply by the rfetch latest PFA store. That ends up rewriting the code field of the most recent word. And semicolon code takes care of all the minutia. It controls the forth nesting. It loads the address into W of the high-level code, and then it jumps to execute that code. In 1982, Chuck introduced the new does. So you see, now we have the very same code, except bills has been replaced by create. In the compile form, the code field contains do colon, and then create comma, and then does has compiled inline this paren, do does greater than, closing paren, and a cell, a 4-byte cell pointing to the following cell, which contains a subroutine called jump subroutine do does. This little code is the magic inside that makes the word, the child word, link to the code that follows the @ sign and the drop. So the child header, its code field address points back to that cell that contains the address one cell ahead. So for those of you in the know, this is the very same structure that a code word enjoys. You have the code field address pointing to a forward pointer and then pure machine code. So Chuck's method in this is to use the subroutine call to locate the source of the code, the @ sign and the drop. So the paren does create the state code word that is the here plus cell and the jump subroutine. And when the child executes, it locates the inline code that holds the 1, 2, 3, 4 placed on the stack, and then it jumps to execute that @ sign and drop. The advantages. Well, first, we no longer need the word bill, so it saves one word that has only one purpose, and now we share the use of create. It uses the inline code for our interpretation. That's the little magic in the middle, but it has a cost. And that cost is there's an extra pointer in the child word that is not needed in the old format. In the old format, the child word has this extra parameter, and with the new structure, that extra parameter is no longer needed. And finally, a tick will properly return the parameter address in child. As we'll see in a moment, having that extra value in the child word in the bill does form means that tick returns the address one cell before where it actually should return. So how do we do this in Win32.4? The key element here is that all code must be in the code memory allocation. This is due to the split headers. Code words have their header in the application dictionary, application portion of the dictionary, but the actual code must be in the code segment. So therefore, this simulated inline code can't be used. So Andrew came up with a solution, and what he does is he places the little code fragment into the code portion, and then he uses the create does defining words to locate that. They locate that runtime portion of the child word. And then the normal do does is executed. So the paren do does greater than paren is the key. It creates this unnamed code fragment, which I'm calling code do does. This is tucked away in the code portion of memory. It's a silent process. It has no head. It is just a short snippet of code. The proto do does places uses the move to W the execution address of parent. This means that in register W, we now have the address of the high-level code in the parent word. This is done by compile. Then we compile a long relative jump that exists in do colon. And do colon does as we expect. It places the child's parameter address on the stack, directs execution to the address in W, and then execute next, which takes us to that high level, interpreting that high level code in the parent. Here's a picture of how it's done. The parent word creates the new word and executes do does. We have the proto code in line, fetch the drop on next. In the child word, the code field address in the child word points to the proto does. In the proto does, we see the machine code for moving W, taking the address from after the proto does. Now, the address after the proto does is the machine code or the high-level compile code that it's going to jump to. Then it jumps down to do does, and we'll go through the regular steps of preparing for the interpretation and putting the parameter field address on the stack. So we've seen three different methods. We've seen the original bills does, we've seen the original create does, we've seen the bills does that came in set in 82, and we see the current value. Now, Chuck introduced this at the formal conference in 1982. When he simply described it in about 4 sentences, the place went silent for about 3 seconds, and then broke into a hubbub of discussion as people in their head did the compiling process, visualized what the code structure looked like, and saw what beauty it was. There's another approach to this process which uses semicolon code. We'll discuss that some other time. So, its conclusion, the create does and semicolon code can actually be used as a core of a meta compiler. In doing this, there would be a number of forward references, but every word that in a forth system can be defined by create does and semicolon code. Currently, in the meta compiler, these words are just adjuncts and used to define a few other words, such as in the assembly. So we've seen a quick tip through the history of create does from about 1969 to the current. I hope you all found it useful. And now I'll return back to Kevin, our fearless leader.
Wasn't ready for that. That was quick. Thank you, Bill. Are there any questions or comments for Bill?
I have a comment. Bill, you are reading our mind. We needed this talk because we're right at the point where we're going to be implementing create does. So we kind of coded it, pieces of the functionality in the outer interpreter, which has to be factored out into, specific functions that our create does. So you helped our project along. Dimitri and I were just talking about this morning on a video call. So thank you very much for that.
Good. Glad to. Thank you.
I always wanted to take create does and rename create to builds because I liked the symmetry, but never did.
It is one of those odd sort of someone seeing create does is sort of like why that shape to it. The builds does sort of made self-consistent sense, but history, I guess.
As kind of an aside or an expansion, I think at this same conference in '82, I presented an alternate construction for Bill's does that totally got lost in the excitement on Chuck's improvement. And the version I had uses Bill's does, but it reverses the syntax order. The does part comes first. So you execute the does as a freestanding word. It creates the does run part, and then it leaves the address of that run part on the stack. Then Bill's comes second, and Bill's the new word, and then inserts the runtime parameter into it. So we've done a reverse Polish. We've actually put the operand declaration, which is the runtime, first, and then secondarily we take the operation part second, which is create the new word. And this really simplifies metacompiling, and of course it separates into two separate words. You have a create word and you have the bills word, but it vanished into antiquity. It's still in the formal proceedings from years ago. And anyway, if I ever did a brand new metacompiler, it's the structure I would use for a metacompiler.
So your talk is, of course, also reminding me that I'm a terrible person with ESP32 forth, and have my implementation of create does is actually does not use the correct trick here. And I was aware of the trick that's required, but it requires generating machine code on in the target, and so I actually have still that sort of builds does-y dichotomy, and then made all the other words smarter to work around it. So like tick has to be aware of, oh, this is a does word, so the the parameters are one hop over, and I need to circle back and fix that actually, because it's rather wasteful and inefficient. So.
Well, if you wait for the online version of the talk, you can go to YouTube and see it, presented for archival purposes.
So yes, you've done a good thing here for educating us all, Bill. Thank you.
Bill, tell me what the advantage of doing does first. I didn't quite understand the difference from creating a word in the dictionary and then compiling first and then creating.
All right. Imagine we're making an opcode. First thing we would write does. We would write does, and it will create inline the high-level code that the opcode will ultimately execute as a code fragment. There's no head on it. It's just the runtime portion, and its address is left on the stack. Okay. Then the create word makes the word opcode, op-code. It makes the generating word, and it receives from the stack the address of the runtime code. It then builds the defining word. It creates the creating word and tucks into it the address of the ultimate runtime code. So in the last stage, when the opcode actually executes, it creates the new opcode word, and it has retrieved from storage the location of the runtime code, and it passes that into the new defining word. Send me email and I'll send you. I rewrote the paper, so we have, and I actually gave a talk on this here at Silicon Valley Fig. I gave a talk on this about 4 years ago, and I can actually send you the actual talk, and it may be in the archives, but it'll be a little hard to locate. It's very, I think it's must I say, I think it's brilliant, but it goes against the grain. I guess you might say it's solving a problem for which it's an answer for which there is no problem. The current system works fine, so why do we need it? I think the only time we would find it of value is doing metacompiler. It makes metacompilers easier and minimizes forward references.
If you can't find the YouTube video, Don, drop me a line. I generally have pretty good success either looking on the back agendas on the SVFig website that Dave has been kind enough to archive, or just directly searching YouTube.
In all modesty, I call this Bill's Does, BILL''S, Bill's Does.
Yeah, Dimitri will be online here. He had to take a call from his brother. So we're going to be kind of doing more of an impromptu workshop and pulling AI into the Core 1 development. It should be very interesting. and then we want to have a brainstorming session after. But I need all of your crate does work.
So you'll note that Chris